So I wrote this hint on the homework too, but sometimes it helps to see it in video form and have someone talk through it. So you're going to end up using this form, P of t equals P0 e to the RT. And that's the standard, of course, standard form for exponential equations we've been using with continuous growth. But I don't tell you what R is. And so there's not an R to just plug in. And instead, I ask you to go find the population of California in 2000 and the population in 2020, which, of course, Google search will do that in 10 seconds. And use that to figure out what the growth rate is, right? And so that's a little bit trickier, right? That's a different thing to do. So let's say I had 2 points, let's say 0, 10, and 5, 38, right? Let's say that those are my 2 points. And I want to find some function of this form that goes through them. Well, here's the thing you want to see. This is t comma p of t, by the way, right? Just in the same way that you would have x, y, right? T is playing the role of x, and y, of course, is p of t. So here's what you want to do. So I know that at t equals 0, y is 10, and then 5 t's later, so 5 years later, t is 38, or p is 38. So I can think of like, this is my initial starting point. This is p of 0 here. And then this is going to be p of 5. So what I can do is say that, well, p of 5 is 38. And that equals the starting value, 10, times e to the r, and then t. It's been 5 years here, right? We went from 0 to 5. So it's like it's been 5 years since my initial value. So we can do that. And then use that to solve for r. You just solve for it like it's any variable, then you plug it back into your original function, right? I'm not going to finish that to give it away. I want you to have something left to do, but that's the basic idea, right? So I got 38 equals 10 e to the 5r, and then I can take the log of both sides, etc. So that's really what I wanted to show you. That's kind of where I want to leave it. I'm gonna go ahead and pause and make sure that I'm saying everything I want to say here. But I think that's about all I want to say. All right, I had one more thing I wanted to say. It's about your answers in part F, where I'm asking you to think about the efficacy of the model. A lot of students make the mistake of thinking that I'm asking a question like, do you think you did the math right? And that's not the question I'm asking. The question I want to ask in part F is, how effective do you think this model is on short, medium, and long-term scales, and why? So I will give you a hint that you should look up like a population graph of California and see if it seems like it fits the pattern that you would get from an exponential equation. And I'll stop there. But okay, one more thing. I'm much more interested in you using your own thoughts than looking up what somebody else would say about this. Because my goal with a question like this is not so much for you to be an expert population modeler right now, right? Just because when you just learned about exponential equations. My goal is for you to think about the efficacy of this model and extrapolate that to the efficacy of other models that you might see in, say, popular culture or in the news or whatever, and potential inadequacies of some of them. That's really kind of what I'm trying to get you to look for here. And so that's what I really want in your answer too. Don't worry too much about what other people would say about it. I want you to think about it, and by thinking about it, of course, that causes you to get better at it. So that's my goal here. And so if you're worried about what your answer is in F, if you've given it a lot of thought and tried to answer thoughtfully, your answer is going to be good, even if it's not right. I'm much more interested in a thoughtful wrong answer than an unthinking right one. Okay, that's really what I wanted to say here. And I'll go ahead and stop now and see you guys in the next video.